So 5.2 is going to be titled Logarithms and Logarithmic Functions. You guys remember that function we just had up there that she was asking about, Piper was asking about the $100 difference? Mm-hmm. And we said we got to figure out what type t. T was an exponent and all that, wasn't it? Yeah. Okay, what logarithms do for us, kids, logarithms allow us to solve, and I'm going to write this right here. Let me get my tools out. So logarithms are going to allow logarithms allow us to solve exponents. Okay? Logarithms are going to allow us to solve exponents. Let me ask you this question, kids. 4 to some power is equal to 16. What's the power? 4 to some power is equal to 16. What's the power? 2. Okay? Now we can do some of these mentally, I think. And you guys remember that nth root chart that we had last chapter? That might come in kind of handy this section for some of the things that we're going to look at. But when we get into this, kids, today, logarithms are going to allow us to solve for exponents. So the essential question today is this. What are some of the characteristics of the graph of a logarithmic function? So to be able to answer that, we have to be able to define and evaluate logarithms. I'll show you what that looks like. We're going to use inverse properties of logarithmic and exponential functions. And then we're going to look at graphing stuff. And again, graphing, where are we headed to? Decimals. Okay. So let's get our vocab taken care of first here. First one's the new one. It's pretty important. It's called logarithm of what? Y with base b. All right. How about a volunteer to read that definition? Who wants to read that for me? Thanks, Maddie.
Let b and y be positive real numbers with b not equal to 1. The
Logarithm?
Logarithm of y with base b is denoted by log by and is defined as log by equals x if and only if b times x.
Okay, and that's a typo. This should really say b to the x power right here. So make that say b to the x power equals y. And I'll write this over here in that empty box again, okay?
The expression log by is read as log base b of y.
Okay. There's a lot of reading and a lot of stuff that may not make sense. This is what I want to really hammer home with you, okay? The way you read this right here, guys, is this. You're going to see me put stuff in this format right here. This b is a subscript. Okay. This is read as the log of base what? Okay, the way I read this is the log of base b of some number is equal to y, or the log base b of x is equal to y. Here's what I want you to understand. This works, and they tell you this, if b to the, whoops, I've got this wrong, don't I? I've got the y and the x switched around. Back up, kids, back up. I didn't read that in there. This should be the log base b of some value y is equal to x, the way it's printed in here. My mistake. This works if this is true, okay? If b to the x power is equal to y. Okay? Here's what I want you to understand. Here's what I want you to understand. If you can think of it this way, it says log base b of x is equal to y. Understand this. In this notation right here, b is always my base. It's the base value that we're talking about. And then if you can understand over here, this is x. This is like the exponent. Then y right here is just some number that would make the equation true. And I'll show you what this looks like here again. But understand this. In this form, b is always the what, kids? Base. And the number over here is always my what? And think about it. guys, when I look at this part right here, these two equations are equivalent to each other. Okay, they're kind of inverses of each other, if you will. In this expression right here, what's the base? What's the exponent? So same thing, you can think base, exponent, number. Base, exponent, number right here. I think you'll be in good shape. Okay? And we'll look at a lot of examples that explain this. But I'm going to tell you right now, this formula that I've written up here, whoops. Make sure you highlight it, but be able to refer to it, okay? But understand what b, y, and x mean. B is my what again? Base. The x over there on the right is the exponent, and then y is just the value you're working with, okay? So guys, a common logarithm. Next vocab term. A common logarithm is a logarithm with base what?
10.
It is simply denoted by log 10 or simply by log. So if you just see log, if you see the word log written right here, and there's no base down here, you assume that that's the same as log base 10. Okay? So if you just see the word log, that's the same as log base what? 10. If they don't put a number down there, you assume 10. Okay? If they want it to be something other than 10, they will put a number down there or a subscript down there. All right? Do you guys have your calculators handy? Make sure you can locate the logarithm button on your calculator. How many have the little, oh, I think these are the greatest calculators in the world. These little guys, the TI-30X2S. You guys find your log button right here underneath the second function?
Yeah.
Miss Ellie and Sam, have you found the log button on yours? Okay. Anybody having trouble locating the log button? Anybody using like an iPhone or anything for a logarithm? Have you got it? I don't think it matters. I would probably use this one. Good? Okay. Find it? Okay. Make sure you're able to find a logarithm. Then guys, there's also going to be a natural log that we're going to talk about. A natural logarithm is a logarithm with a base of what? Man, we just got done talking about that. It can be denoted by the log of e, but it's usually denoted by ln. So if I have log base e, this is the same as natural logarithm. That's all that's saying. If they say, oh, by the way, we're going to use base e this time, which is the natural base, they put L in there for logarithm natural. I don't know why they didn't put NL in there, but whatever. Natural log, okay? And then inverse functions. We've talked about inverse functions, okay? Specifically that f of g of x has to equal x, and g of f of x has to equal x. And I'll show you what the inverses are for logarithms here in a bit. So this is review. But maybe just get that notation down. Two functions are inverses of each other. Two functions f and g are inverses of each other if f of g of x is equal to x and g of f of x is equal to x. And we'll talk about that as we progress. So who needs more time on the first page? Getting vocab notes. Let me know when you're ready, okay? Everybody found the log buttons on their calculator? Yeah, are we cool with that? Awesome. Oh no. All right, let's get rolling here. Top of this page, I'm going to write this down again. I want you to do the same thing. Which variable up here represents the base? Which variable represents the exponent? Which variable represents the value I'm working with? This is true if this is true. The left is true if the right is true. So number one, it says rewrite each equation in what? Okay, exponential form. Exponential form is the form b to the x equals y. Okay? Down here, this is read as log base what, kids? Log base 6 of 216 equals what value? Okay, we need to write this in exponential form. The exponential form is of the form bx equals y. What are you plugging in for b, given this information right here? 6 to the third has to equal what value? By the way, somebody check 6 to the third in their calculator. Okay. This is simply saying right here, kids, this is simply saying the cube root of 216 is 6. Okay? Does 6 to the third equal 216 in your calculator? Okay. You guys write the next 3 right here and then check with the neighbors. See if you agree. Someone in this row. What's the next one?
7 to the 0 power equals 1.
Guys, does 7 to the 0 equal 1? So is this statement true? You bet. How about this row? Who's got this one? That's true. Somebody in this row. 1/5 to the -1 equals 5. I agree. I agree. You guys understand how to take a logarithmic function and turn it into an exponential function? Well, guess what we're going to do now, kids? Going to go backwards. We're going to take an exponential to write a what? Logarithm. Okay? So that's exactly what example 2 says. Hey, take those written functions. You guys agree these are all exponential functions right here, kids? They say turn them into what? So we want to put it of the form log base b of some value y is equal to your exponent. That's what we're turning this into. So you guys help me with the first one. How am I going to write this first logarithmic function? Well, it's pretty simple. Going to have the log of which base there, kids?
9.
Okay, so the 9th base. So the log base 9 of some value is equal to your exponent. What value is going to go after log base 9? 81. That's going to equal your exponent of what?
2.
Okay, on your own. Finish the next 3. When you've got them, check with the neighbor.
Somebody's got the kazoo things over there.
Who needs more time? Who wants to tell me the next one? Yep. Awesome. Who wants the next one?
Log
Okay.
16, 8 equals 3
You got it, kid. Pat on the back. Last one. Log base how much, kids? Of?
1 over 25, 1 over 2.
Yes.
Queens.
Think about it, kids. 15. This is really 15 to the negative 2 power. Okay, well, you understand how to go from logarithmic functions to exponential functions and then back again? Okay, that's all example 1 and 2 are. That's pretty simple, isn't it? Okay, honestly, it's almost too simple, isn't it? Bella's laying on her side shaking no, which really means yes. Okay? All right, so let's get into this and let's evaluate this. Now, guys, this is where I get kind of concerned. Example 3. People are like, all of a sudden they see this and they're like, Parson, I don't know what to do. And I'm going to be like, okay, let's talk. A couple of different ways we can do this. Okay? First of all, this says log. I don't know why that G is like that, but this should be log base what here, kids? Of 256 is equal to, there's no equal sign in any of these. So I like to put an equal sign in all these. I'm going to write X. Okay, so this is saying really 4 to what, kids? 4 to some power is equal to, okay. And I think that this is where the chart can come into play. So I'm going to jump back into that chart that I have on my website. Let's find that quickly, kids. Where is Mr. Parson? Whoa. Calculators and resources. What did we call that? Like the nth row chart? Is that what we called that? Perfect nth row table. Okay. Kids, here's a question for you. We're dealing with what number here? What's our base again, kids? Okay. I don't want you looking at powers anymore. What I want you looking at is bases. So I'm going to come down here to a base of 4, right in here, okay, and follow this all the way over to, I get to what value? 256. So 4 to what power makes 256? 4 does. So let's write that in there. Say, oh, Parson, the answer for this x equals 4. Because 4 to the 4th power would equal what value? Well, 256. Okay? Now this next one. I don't know how to tell you this. I might jump ahead here. Okay? Do you guys have a fraction decimal button in your calculator? Okay, type in 0.125 in your calculator for me. Okay, do you guys have 0.125 just typed in there? Do you have a button that has like F arrow D or something like that in there? An F and then a D that changes decimals to fractions or fractions to decimals?
Yeah.
Punch that button. What do you guys get when it turns that to it? 1/8. Is there anybody that doesn't know how to hit that fraction decimal button? Ellie, Sam, can you show her? I think you have the same calculator. Okay, here's the deal, kids. This is kind of the same as saying log of 8th base is 0.125 is really what value, kids? Okay. So think of it this way, kids. This is like 8 to the x power equals 1/8. Kids, when you start getting fractions like this is where exponents start becoming negative. So think of it this way. Look at the denominator right here. What is the denominator? 8. So, kids, how many powers of 8 would I need to make 8 in the denominator? 1. But since this 8 is in the bottom, this x value should really be what? -1. I'm going to tell you this right here. If your base value or your value up here is less than 1, between 0 and 1, typically you're going to have negative exponents. So what this means is x is equal to -1. So do this, kids. Type in 8 to the negative 1 power in your calculator. See what it spits out at you. .125, okay? All right, let's do the next one. Let's write this as equals x. Okay, so this is going to be 1/3 to the what, kids? One-third to the x equals what? Okay, now this is kind of a tricky one. Let's talk about it. If that was 3 to the x equals 27, kids, 3 to what power would make 27? Third, right? But this is not 3. This is 1/3. It's kind of the opposite of 3. So instead of 3 to the third being 27, 1/3 to the, not positive 3, but negative 3 might make this work. Okay? So x is going to equal negative 3 here. And if I punched it in, 1/3 of the negative 3 would be 27. Now, I'm going to do something in this last example. And it's going to come up in a few sections down the road, but I'm going to try and make this a little easier for you rather than trying to have think values on your own. Is that okay? You got it? What's the answer? I like it. Okay, 64. How'd you get it? Do you have a button in your calculator that gives you a base of 64? What's that?
Of 2 is 1/2.
So you're thinking 8 squared?
Yes.
So we start with a base of 64 and we come down to 8, right?
Yeah.
So you're kind of thinking 8 squared is 64, but since I came down, the inverse of that 2 would be the 1/2. I like the way you're thinking. That's awesome, Xavier. Okay? I'm going to give you a little bit cheater ways to do this. Is that okay? Is that okay?
Yeah.
Okay, do this for me. Anytime you have a logarithm written like this, okay, and I'm going to put a star by this, and this is going to be the cheater's way of doing this. Okay, and we'll talk about why this works in later sections. Are you okay with that?
Mm-hmm.
Do this for me. In your calculator, type in log of 8 divided by log of 64. What do you guys get? 1/2, right? Okay. Can I do something here quickly? Can I go back to the second one? Okay, what did I type in first? Log of what, kids? And then log of base on the bottom, okay? Go to this one right here. Go log of the number first. 0.125 and divided by log of what? Go log of 0.125 divided by log of 8 and see what you get. What do you get? Okay, so can I give you a rule to make this a little easier, make life a little easier for you? Okay, when they ask you to evaluate a logarithm, when they say evaluate log of base b of some number y, this is the same as log of y divided by log of b, okay? If they ever ask you to evaluate something, log base b of y, you can take the log of y in your calculator and divide it by the log of b. Okay with that? Okay. Now a lot of this is going to get set up in your calculator here in the next section. But that would be the shortcut. So the log of base b of y, so when I have to evaluate these right here, log base 4 of 256, just do it real quickly. We would do log of what, kids? First. Log 256 divided by log of what? 4. And it better kick out what answer? 4. Okay. What do we get here again, kids? Okay. So if they ever ask you to evaluate, do log of your value out here, log y, over log of your base. Okay? All right. Anyone need more time with that page? Moving on. Last one. Let's nail this down. I think you'll be in good shape. Evaluating common and natural logarithms. Okay, so your calculator, I just want to make sure you're good with this. Evaluate log 21 using a calculator. Round your answer to 3 decimal places, so go ahead and do that quickly. Log 21 equals what to 3 places, kids? 1.322. I like it. Okay, the next one says evaluate not the log, but which base log? Do you guys have your LN button in there? Let's make sure we all get the same values. When you go natural log of 0.54, what do you get?
Negative 0.616.
So 0.616? Are we all getting 0.616 for natural log of 0.54? Yeah, it should be negative. I'm sorry. Okay. And maybe make a note up here. When we're doing logarithms, typically if your value is between, if the value you're taking a logarithm of is between 0 and 1, typically your answers are negative. Okay, because they're like a fraction. All right, guys, using inverse properties. I need to give you 2 rules up here. Okay? Using inverse properties. You need to know 2 rules. If you ever have, hold on, which one's first? Yep, okay, if you ever have 2 rules, rule number 1. If you ever have log base b of b to the x like this, okay, log base b of what? B. So this is a 7 and this is a 7 right here. If this little subscript for telling me the logarithm of a certain base is the same as the actual base right here, this is going to equal x. Okay? So in this example right here, it says simplify. Okay? It says simplify, and we'll talk about this one here quickly in a second. Your other rule is going to be this one. Yep. If you ever have b to the log of base b of some value x like this, this is going to equal x. Okay? So I'm going to highlight some things. If this down here in this format matches this right there, then what's this equal to? If this base right here is raised to a logarithmic function as a power matches this right here, this is simply going to equal what? Okay, quick question here. What's the base in this problem I'm about to simplify? 10. It's raised to a log, but there's no subscript down here for log, so if there's no subscript for log, we assume that this base is what value? 10. So what is this going to equal in the end, kids? Just going to be 18. Okay? That one's simple. Next one, not so much. Okay? Next one, not so much. Here's the deal. What's the base in this? Does that match that base? Okay, so here's the question you're going to ask yourself. If that log base doesn't match the base that's already in there, could 16 be written as a base of 4? In other words, 16 is the same as 4 to what power? Ooh. Is this really the same as saying log base 4 of 4 squared? Because 4 squared is what value, kids? And what other exponent is still out there? What do you notice about the base here and here now, kids? So what is this simply going to equal? By logarithm rules, this is going to equal 2. Okay? This is going to equal 2. Guys, remind me, we need to finish this up tomorrow when we get to class. Can you do that, number 1? Number 2, I sent out an online for this, so maybe get into it and look at it. A lot of rules going on here. Make sure you have your calculator, okay? I'm going to stop there with this.